Welcome to my YouTube channel. To all of you, my returning subscribers, you guys are awesome. Thank you very much for your support. And if you are dropping by for the first time, please like this video, hit the subscribe button, and strike the bell notification. That way you will be the first to know whenever I post new content. Thank you very much as you do so. In this video, we are going to be discussing the availability services in AWS. Why is this important? Because businesses lose as much as 5,600 per minute as a result of availability issues. So we are going to be diving into all of the services in AWS that supports availability. We're going to be talking about EC2 instances. We're going to be talking about RDS. We're going to be talking about Route 53. We'll talk about health checks and many others. Also, availability is very important in cybersecurity. Availability is the A in the CIA triad. So that means availability is not just good for business, it is also good for cybersecurity. So we're going to be exploring all of the availability details we have in AWS. We're going to be describing them, discussing them, using real world scenarios, of course, and then we're going to be diving into the console to put to test some of the things we've talked about. This promises to be a very exciting session, another session you don't want to miss. So stay with me to the end. I guarantee that you are going to learn a lot of things in this video. Thank you very much as you do so. In this session, we are going to be discussing how to ensure high availability with all of the various AWS services. And by way of an agenda, we are going to be introducing availability services in AWS. We'll look at the importance of availability in cybersecurity. We'll look at some of the key services for availability. We'll talk about some of the best practices we need to bear in mind. We'll look at real world examples, and then we'll wrap it up before we dive into the console to practicalize some of the things that we will be discussing. So let's get started. Did you know that downtime costs businesses an average of 5,600 per minute? That is why understanding availability services is crucial. And in this video, we are going to be exploring AWS availability services, including best practices and real-world examples to ensure your applications are both resilient and reliable. So let's get started. Now, availability is a key aspect of cybersecurity, and this ensures that resources are accessible when they are needed. High availability is crucial for business continuity, preventing data loss, and providing uninterrupted services. In fact, availability in cybersecurity is one of the core pillars of the CIA triad. It is the A in CIA, and it ensures that information and resources are accessible when needed. Now, it is important for maintaining business continuity, for preventing data loss, and providing uninterrupted services to users. And it ensures that systems remain operational and resilient even in the face of disruption, thereby safeguarding the integrity and reliability of critical services. So, AWS is a comprehensive cloud platform, and it offers over 200 fully featured services from global data centers. It is the preferred choice for businesses, enhancing IT infrastructure with reliable, scalable, and flexible solutions. And it provides high availability tools and services, ensuring minimal downtime and supporting seamless application and service delivery. So what are some of the key services for availability in AWS? We are going to be diving into each of them, and we're going to begin with the basics, which is the EC2 or the Elastic Compute Cloud. Now, EC2 provides resizable compute capacity in the cloud, and this allows businesses to scale based on demand, ensuring application availability during peak times and offering flexibility and scalability. So the EC2s themselves are virtual servers in the cloud that provide scalable compute capacity, allowing you to run applications without worrying about hardware. Now, there are a variety of instance types which you can choose from, giving you the right balance between CPU, memory, storage, and networking capacity. And the best part is you only pay for what you use, which makes it a cost-effective and flexible solution for all of your computing needs. But if you are very, very interested in the serverless side of things, AWS Lambda gives you that ability because it allows you to automatically scale. It gives you high availability and fault tolerance, allowing you to run your code efficiently without worrying about provisioning or managing servers. That is because it is a serverless computing service that allows you to run your code, and it will automatically scale your applications by running your code in response to triggers, which will ensure high availability and fault tolerance. Now, Lambda allows you to focus on what you do best, which is writing code, allowing AWS to handle the rest, which makes it a very powerful tool for building scalable and resilient applications. Now, another service we are going to be looking at is the RDS, or the Relational Database Services. Now, RDS simplifies setup and operation of relational databases, which will allow you to focus on your applications, and it gives you a lot of automated features like backups, software patching, and scaling, ensuring that your databases are always up to date. It has high availability and durability built in, and it provides failover support and data replication across multiple availability zones, which makes it a reliable choice for your database needs. And then, of course, talking about object storage services in Amazon S3, which is a scalable object storage service that allows you to store and retrieve any amount of data from anywhere. It gives you high availability, ensuring that your data is accessible whenever and wherever you need it. It gives you exceptional durability, automatically replicating your data across multiple devices and facilities, and providing you a robust protection against data loss. It is designed to have 11 nines of durability because it will automatically create and store copies of all of your S3 objects across multiple systems. And then we have the Route 53. Now, Route 53 is a scalable DNS web service that routes end-user requests to applications reliably and cost-effectively. It ensures services remain accessible with health checks and failover mechanisms, monitoring and maintaining service availability. Now, it gives you traffic management features, and it optimizes the distribution of traffic, providing a robust solution for managing your web traffic. So, what are some of the best practices that we can put in place to ensure high availability? The first would be to deploy our resources in multiple availability zones. Now, multi-AZ deployments in AWS are designed to enhance the availability and reliability of applications because they will be distributing resources across multiple availability zones, which will be ensuring that your applications remain operational even if one availability zone experiences an outage. Now, this gives you high availability because you will be putting all of your resources spread across multiple availability zones, ensuring that your applications will continue to function even if one of them were to go down, which will ultimately be minimizing your downtime and maintaining your service availability. It also gives you a lot of fault tolerance, giving you redundancy. So if one AZ fails, the other one can take over, which will ensure that your application will remain accessible. And of course, it also gives you disaster recovery. Now, in the unlikely event of a disaster, having resources in multiple AZs is going to allow for quick recovery and continuity of your operations. So these multi-AZ deployments play a very important role in maintaining operational continuity. And this ensures that your applications are resilient to failures and they can handle unexpected disruptions. So by automating, replicating data and resources across AZs, AWS will give you a robust infrastructure supporting seamless failover and recovery, which will keep your applications running smoothly. Now, another thing you want to do is you want to do a lot of health checks. Now, health checks and monitoring are important when it comes to maintaining the reliability and performance of your applications and infrastructure. They allow you to detect issues early, helping you to identify problems before they impact end users. And of course, giving you a lot of proactiveness when it comes to mitigation. If the issues are detected early, then you are in you are in a better situation to mitigate the problems proactively and prevent potential downtime and service disruptions. And there are a lot of tools for continuous monitoring, including things like CloudWatch, giving you real-time monitoring of your AWS resources, and of course, AWS Health Check, delivering personalized information about your AWS infrastructure. You could also have real-time insights by way of continuous monitoring, which is going to be allowing you to keep an eye on the health of your resources, ensuring that they function optimally. And of course, you can track service performance so that you can identify trends and potential issues, allowing you to take corrective actions promptly. Another key thing is auto scaling. Now, auto scaling is a feature that maintains application availability because it will automatically adjust capacity to ensure steady performance, optimizing resource usage, reducing unnecessary costs, and enhancing cost efficiency. Now, with continuous performance monitoring, auto scaling will adjust capacity to meet performance levels, ensuring your applications run smoothly and run efficiently. Now, we're going to be looking at some of the real world examples and some of the real world scenarios that have leveraged some of these services to be able to deliver cutting edge services to end users. And we're going to be looking at Netflix. Now, Netflix leverages AWS infrastructure to maintain a 24/7 streaming service, utilizing a wide range of AWS services that ensure high availability, scalability, and reliability. Now, they use EC2 instances to handle core tasks like video streaming and managing recommendation engines. And of course, they leverage S3 to store vast quantities of content, including series, movies, and backup, providing the necessary scalability and reliability, ensuring data remains accessible and secure. They also use video transcoding, leveraging AWS Lambda to deliver content to various devices with specific resolution and format needs. And of course, through the use of Lambda, Netflix can dynamically transcode these via videos based on device type, optimizing playback quality without the need to manage infrastructure. And of course, all of this is controlled by Amazon CloudFront that caches content across a global network of data centers, which will ensure minimal latency and quick delivery of videos and TVs. So, what are the infrastructure benefits? The benefits include high availability, leveraging the AWS global network of data centers to ensure high uptime and quick recovery, leveraging scalability, which allows Netflix to scale its infrastructure based on demand, leveraging reliability, because AWS provides a resilient and secure environment that allows Netflix to focus on delivering smooth, high quality streaming experience. And of course, all of this is done in a cost efficient way because AWS offers pay as you go models, allowing Netflix to optimize cost by scaling infrastructure based on demand. Now we have a typical infrastructure architecture example here. And we can see here that auto scaling gives us several key benefits. First, of course, it maintains application scalability, ensuring that our applications always have the right amount of capacity to handle the current traffic demand. It also gives an automatic adjustment of capacity because it dynamically increases or decreases capacity as needed, ensuring steady performance by automatically adjusting this capacity and of course doing all of this in a cost efficient way and continuously monitoring applications and adjusting capacity to meet performance levels that will ensure that our applications run smoothly. So in the next part of this video, we are going to be diving into the console. We are going to be implementing some of these things and we're going to be going from there. So please stay with us. It promises to be a very exciting session. Thank you very much as you do so. So we are in the AWS Management Console and we are going to be putting to practice some of the things, some of the conversations we had in the previous section. So here, we're going to first of all go to the VPC console because everything we're going to do is going to be sitting in the VPC. But I'm not going to create a VPC because the conversation here is not about VPCs. However, I'm going to be showing you that there is always a default VPC created. We're going to just be using that. Okay, maybe we're going to have a detailed conversation on VPCs in a future video. Okay, so this is the VPC here. We'll look at the details. We can see the state of the VPC and the VPC ID. We can see the IPv4 CIDR. We can see the DHCP option sets, the route table, the main network ACL, the tenancy. We can see here that it is the default VPC. And if we get into the VPC, we are going to see some more details. We can see the resource map. We can see the subnets. Currently, there are 3 subnets in the VPC, 1 route table, 1 internet gateway. If we want to see the details of the subnet, we'll go to the subnet here and we can see all of those kinds of things. But of course, like I said, this conversation is not about VPCs. We'll just go ahead and start what we want to have created. So we want to create an EC2 instance. So I'll go ahead and click on EC2 from the home page. And I'll go ahead and go into the instances. And since I've not created any recently, we can see that this is blank, but that's going to change in a minute because we are going to actually launch a couple of instances here. Now, this is the launch an instance page where we want to give an instance a name and tags. So I'll go ahead and call it my, for example, first demo instance. Okay, so I'll give it a name. You always want to give it a name, and then you want to go ahead and choose the OS image. I want to go ahead and from the quick start images, I want to choose Amazon Linux, and I want to choose a free tier eligible Linux instance. So that's the Amazon Linux 2023 AMI, which is what is currently selected by default. You have the option of choosing the architecture, either the 64-bit x86 or the 64-bit ARM. I want to stay with the default using the x86 64-bit. And then we've got the instance type. We have a whole lot of options to choose from here. I'm choosing the T2 micro because in the first year of your having an AWS account, it includes 750 hours of T2 micro. So I'm going to be choosing that because it is free tier eligible. But take note that you have other ones depending on what you want. And like we said in the previous section, the instance types combines a lot of things, CPU, memory, storage, and networking. So I'm going to be staying with the T2 micro. We can see it's the T2 family. It's got 1 vCPU, 1 gig of memory, and all of those kinds of things. Yeah, if you want to see some additional generations, you want to go ahead and toggle this button to on, and you're going to see some more. In this case, I will not be using SSH, so I'll go ahead and select proceed without a key pair. That is not recommended, but just to make things simple, I'm going to go with that option. I will, however, create a security group. So I'll go ahead and create a security group. And since I'm not going to be using SSH, I'll just go ahead and uncheck this. And then I'll check these other 2 boxes here to allow HTTP traffic and HTTPS traffic from the internet. And then I'm basically done. I'll select the default options for storage. I'll expand advanced details, and I'll just allow everything to be the default with the exception of the user data. Now I'm going to include the user data details, which is going to do a number of things. First of all, it's going to install the HTTPD after doing an update, and then it's going to go ahead and start the HTTPD service. It's going to enable the service, and it's going to now write this into the var www HTML directory here. It's going to write this is my EC2 instance, which we are going to see at the point where we are going to access the instance. Now, since I'm going to be using multiple instances, I can go ahead and select the number of instances I want to create. Of course, after I've done that, there will now be 2 instances with the same name. But of course, at the end, I'm going to go ahead and change the name for the second one so we are better able to identify it. And that's basically all I want to do here. I'll go ahead and click on launch instance. and we see that the process of instance launching is underway. So if we go back to the instances now, we're going to see after a refresh here that we have two instances coming up, but of course still in the initialization phase. And if I expand this right here, we can see that we have two instances and they both have exactly the same name, which I'm going to change. So I'll go ahead and change one of it to my second instance. So I'll just go ahead and call this second. And that's basically all we are going to be doing. So I'm just going to pause the video at this point and wait for the instances to be fully initialized, and then we're going to proceed from there. So it's been a few minutes, and let's go ahead and do a refresh and see if our status is now as it should be. It's still on the initializing. Let's go ahead and do a refresh. And of course, we can see here that two checks of two have passed. So first of all, let's go ahead and see if our web HTTP service is running. So I'll go ahead and click on the first instance, and then it's got a public IP, which I'm going to copy. And then I'll go ahead and launch a browser, and let's see. We can see here, this is what I sent to the HTML document. We can see that this is my EC2 instance. It gives me the IP of the instance. Of course, it tells me where the instance is. And I can go ahead and do the same thing for the second instance. I'll go ahead and copy. And I'll do the same thing. And we can see here that we have, though they are similar, we can see that the IP address of this one is 172.31.31.35, and the other one is sorry, I just refreshed this, and the other one is, I think maybe I copied the two at the same time, 172.31.31.35. Okay, so it's the same thing I copied, so I'll go ahead and copy another one. Let's see. Okay, sorry. Okay, so I'll just copy this, and I'll just go ahead and paste. Okay, so we can see 172.31.18.64, 172.31.31.35. So we can see here that we are able to access the HTTP service on each of those instances individually. But what if there was a way that we can actually access the two services, the two HTTP servers from one service? And yes, there is actually a way that we can do that. And for us to be able to do that, we need to go ahead and create a load balancer. So let's go ahead and see what load balancers are. We'll talk a bit about them, and then we'll create one and see how it works. So here we want to go ahead and create a load balancer. So we can see we currently have no load balancer available. So I'll go ahead and create a load balancer. Now we have a whole lot of choice here. We have three different types of load balancers. We've got the ALB, or the application load balancer. We've got the NLB, or the network load balancer. And we've got the GLB, or the gateway load balancer. So point is, what do all these things mean, and why should we care? Now let's start with the first one, which is this one, the application load balancer. Now the application load balancer here, the main thing it will do is it will be directing incoming traffic to multiple targets. And these targets could be EC2 instances, they could be containers, they could be IP addresses. What the application load balancer does is that it ensures high availability, it ensures automatic scaling, and it also enhances the security of all of our applications, because it will be making sure that our applications run smoothly and applications run efficiently. Now, there are specific use cases for the application load balancer. For example, we can use them in microservices architecture when we want to route traffic to different microservices, which this routing could be based on URLs, could be based on host names, and of course, we could use them for web applications as well, where we want to distribute HTTP and HTTPS traffic across multiple servers. We can use them in real time applications, amongst other different kinds of use cases. That takes us to the second kind of load balancer, which is the network load balancer. Now, the network load balancer here, we want to use them for high performance scenarios because they are designed to handle millions of requests per second and have ultra low latency. So what it does basically is it will distribute incoming traffic across multiple targets, ensuring seamless and reliable application performance. We want to use them in areas where we have high traffic websites. We want to manage spikes and ensure consistent performance for high traffic websites. We want to use them for things like gaming applications, for financial services, and even IoT. So that's the network load balancer. And then there is another type called the gateway load balancer. And the gateway load balancer here, we'll be using them to scale and manage third-party virtual appliances like firewalls, IDS or intrusion detection systems, which it will be using it to enhance availability and efficient distribution of traffic across multiple scenarios. We'll be using them in specific use cases for security appliances, for traffic inspection and centralized management. Now, there is yet a fourth one, which we are not just going to be emphasizing because it probably is not going to stay for much longer because it's in the process of being deprecated, and that is the classic load balancer. So I'm just going to mention it and I'm not going to say anything further about the classic load balancer. Now, for the purposes of this demonstration, what we want to do is we want to create an application load balancer. So I'll go ahead and click on create. Okay, so again, as usual, we want to give it a name. I'll just call it my web. I think I'll use dash. All right, I'll just give it that name there. So I'll give it a name, my web server ALB. We want it to be internet facing. The IP address range type is IPv4. And right here, we want to specify, of course, the load balancer here, the VPC. So we see it's going to be sitting on the VPC that we have, which is our default VPC. And I want to deploy it across the 3 availability zones. I'll go ahead and check each of the availability zones, for example. And then for the security group here, we have options that we can choose here. I want to, in this case, we can select up to 5 security groups. We already have a default security group here, but I can go ahead and create a new security group. So I can give it a name. I can call it my web ALB SG, for example. And then I can give a description. I can say I want to allow HTTP traffic to the ALB, for example. Of course, I can go ahead and now add a rule. Okay, I can say, let's see, I want to go ahead and add an inbound rule. I'll go ahead and add a rule. I want to allow only HTTP traffic, for example, coming from anywhere to be able to get into our application load balancer. So we can see here that we have an inbound rule, and of course there is an outbound rule, and that's exactly what I want created. So I'll go ahead and create the security group, and the security group is created. So I'll go back here and remove this default, and then I'll go ahead and let's see. Okay, I want this to be the security group that I want to create. Okay, so I want to go ahead and okay, there is a listener here. I'll go ahead and I'll create a load balancer. Okay, so it tells me I've got to specify a target group. Okay, so I have to go ahead and create a target group. So in this case, I'll click on create target group, and basically a target group is just a group of EC2 instances where I'm going to be sending where the ALB is going to be sending traffic to. So I want to specify the details of the group. It's going to be for instances, and of course we want to give our target group a name. I'll call it web server ALB TG, for example. And of course, the port protocol is HTTP. The IP address type is IPv4. The protocol type is HTTP1. And I'm going to go ahead and click on next. And I want to go ahead and register the targets. Of course, I want to go ahead and select these two, and I want to include them as pending. So these are the targets, which of course are the EC2 instances I created earlier on. And then I want to go ahead and click on create a target group right here. So back to my application load balancer, I'll go ahead and refresh, and then I'll select the target group. And then I think that's about all I want to go ahead and do. I'll just accept the defaults after that and go ahead and create the load balancer. So if we it's telling us that our load balancer is created successfully. Let's go ahead and see what's going on here. We see that our load balancer is currently in the provisioning stage. So I'm going to go ahead again and pause the video, and by the time I come back, our load balancer would have been created. All right, so we're back, and let's look at our load balancer and see exactly what's going on. I'll just do a refresh, and we can see that our load balancer is in the active stage. And if I go and select it, we can, let me just go back. We can see that our load balancer has got a DNS name. It's a pretty long one. I'll just go ahead and copy this. And like I did before, if I come paste this in the browser here, we can see that if we refresh, if for example, we can see it's currently at 172.31.31.35. If I refresh, we can see it has changed to 172.31.18.64. And if I refresh again, you can see it keeps changing. And of course, it shows us that it's actually juggling the traffic between the two web servers. Okay, so if for any reason now for example, we can see here that our target group has got two targets, which are our EC2 instances. We can see if I go ahead and refresh this, we can see that our two instances are both healthy. My second instance and then my first instance. So if I were to come to the EC2 console here and go to instances, and if for example I select one of the instances and maybe stop the instance, for example, if I go to the target group, the first thing that's going to happen is if we do a refresh here, after some time, it's going to see one of the instances as unhealthy. It might take maybe a couple of seconds. It's still taking some time. Let's go back to our instance and see what's going on. Okay, so it's currently in the stopping state. So if we come here and do a refresh, we can see that the first instance is unused. So if we go back here and we do a refresh, we'll see that that changing in IP address is no longer happening because our EC2, one of our EC2 instances, is now unhealthy. So the load balancer is intelligent enough to know that that instance is unhealthy, so it's not going to be sending traffic to that instance. But if we were to go back and now go ahead and restart the instance, for example, and wait for a couple of seconds while the instance is starting, I will just give it some time for the instance to fully get started. Once the instance gets started, of course, we can see here it's currently unused. If we come here and the instance is fully started, for example, it's now initializing. If we go here now and do a refresh, we can see that the instance is now healthy. So if we go back to the load balancer, we can see now that it again begins to send traffic to the two instances at the same time. So you can see the power in the use of load balancers because it performs some form of health check on our instances and only sends traffic to the instances that are healthy. And if the instance is currently unhealthy, it does not send traffic to that instance. So that is all we've got the time for this demonstration. I hope you enjoyed it. I hope you learned one or two things. Thank you very much for your time. And of course, see you in the next video.